L is a set of straight lines on a plane. A relation R defined on capital L. L1 is perpendicular to L2, where L1 L2 belongs to capital L. Then R is symmetric but not reflexive and transitive. देखो एक प्लेन में जितने सारे स्ट्रेट लाइन हो सकता है उसका सेट कैपिटल है and L1 L2 order pair belongs to R if and only if L1 is perpendicular to L2. Reflexive चलो देखते हैं रिफ्लेक्सिव होता है कि नहीं होता है रिफ्लेक्सिव कब होता है जब L1 L2 belongs to R or all R will be reflexive if L1 order pair belongs to R or all L1 belongs to capital L. L1 order pair belongs to R. इसका मतलब क्या है L1 is perpendicular to L1. ऐसा होता है कि नहीं होता है अगर L1 कोई एक स्ट्रेट लाइन है तो इसी स्ट्रेट लाइन इसके साथ परपेंडिकुलर होगा या पैरेलल होगा L1 L1 के साथ पैरेलल होता है परपेंडिकुलर नहीं होता है so this is not true so L1 order pair L1 order pair does not belongs to R so R is not reflexive R is not reflexive symmetric R relation will be symmetric if L1 L2 belongs to R that implies L2 L1 belongs to R. Now suppose L1 L2 belongs to R. इसका मतलब क्या है L1 perpendicular to L2 अगर L1 L2 के साथ परपेंडिकुलर है तो L2 L1 के साथ परपेंडिकुलर है ऐसा हम बोल सकते हैं तो यहाँ से हम बोल सकते हैं L2 L1 order pair belongs to R so R is symmetric The condition of symmetry is L1 L2 order pair belongs to R that implies L2 L1 belongs to R okay transitive R will be transitive if L1 L2 and L2 L3 belongs to R that implies L1 L3 belongs to R so suppose L1 L2 and L2 L3 belongs to R so L1 perpendicular to L2 and L2 perpendicular to L3 यहाँ से क्या हम बोल सकते हैं L1 perpendicular to L3 ऐसा होगा कि नहीं होगा is it true suppose this is L1 and this is L2 So L1 is perpendicular to L2. So this is pi by 2. Also, suppose this is L3. This is pi by 2. So L1 L2 के साथ perpendicular है and L3 is perpendicular to L2. The angle between L1 L3 is pi. So L1 is not perpendicular to L3. Okay. So L1 L3 does not belongs to R. So this is, so R is not transitive. Not transitive. So relation R is symmetric but not reflexive and transitive. Okay. Here R is a relation or a set of all natural numbers n such that xy order pair belongs to R. That implies y is divisible by x for all xy belongs to n, and show that R is reflexive, transitive but not symmetric. Okay. तो xy order pair R के अंदर कब होगा जब y is divisible by x. Okay, where xy natural number. R will be reflexive if x belongs to R for all x belongs to n. If x is a natural number, x order pair belongs to R for all this type of natural number, then R will be reflexive. When x order pair belongs to R, when x is divisible by x is divisible by x. Now this is true. X is always divisible by x. X is always divisible by x. So x order pair belongs to R and R is reflexive. R is reflexive. Symmetric. Symmetric. When R will be symmetric if xy belongs to R, that implies yx belongs to R. Now suppose xy belongs to R, where xy natural number. Okay, it means y is divisible by x. So we can say y equal to mx, where m is a natural number, m belongs to capital M. From here we cannot say x is divisible by y. Look at 2 4 ऑर्डर पेयर R के अंदर रहेगा कि नहीं रहेगा. 4 is divisible. 4 is divisible by 2. So 2, 4 order pair belongs to R. But 2 is not divisible by 4. So 4 2 order pair does not belongs to R. Okay. So R is not symmetric. So R is not symmetric. Next, transitive. Transitive. When R will be transitive? If xy and yz belongs to R, that's imply xz belongs to R. Then R is transitive. Now suppose xy and yz order pair belongs to R. Then y is divisible by x. Y is divisible by x. That's imply y equal to mx. Similarly, yz belongs to R. Then z is divisible by y. So यहाँ से हम बोल सकते हैं z equal to ny. Here y equal to mx. So put here n into mx. So we get mn x. Here m is a natural number. Here also n natural number. So mn must be natural number. Mn is natural number and z equal to mn into x. So we can say z is divisible by x. Z is divisible by x. Then xz order pair must belongs to R. So we assume that xy and yz belongs to R and we get xz order pair belongs to R. So R is transitive. So R is reflexive and transitive but not symmetric. Okay. Look at the relation. R is a relation on a set of all integers such that xy belongs to R when x minus y is divisible by n. Then show that R is a equivalence relation. Equivalence means it will be reflexive, symmetric, and also transitive. Reflexive. Look at x minus x equal to 0. Now 0 is divisible by n. 0 is divisible by n. So we can say xx order pair must belongs to R. xy order पेयर R के अंदर कब रहता है जब x minus y is divisible by n. So here x minus x is 0 is divisible by n. So x order pair must belong to R. For all x belongs to z where x is integer. So R is reflexive. reflexive. Now symmetric. Symmetric. Suppose xy belongs to R, where xy are integer. So we can say, along the definition, x minus y is divisible by n, is divisible by n. So x minus y equal to p1 n, where p1 also an integer. Look at y minus x will be minus p1 n. So y minus x also divisible by n. Y minus x also divisible by n, as minus p1 will be integer. So we can say yx belongs to R. We assume that xy belongs to R. So we prove it. Yx belongs to R. So R must be symmetric. Okay. Transitive. Transitive. R will be transitive if xy and yz belongs to R. That's imply xz belongs to R. We suppose that xy and yz belongs to R. Now xy belongs to R. That's imply x minus y is divisible by n. Divisible by n. So we can say that x minus y equal to p1 n, where p1 is also an integer. Again yz belongs to R. Similarly, we can say y minus z, it will be p2n. Y minus z must be divisible by n, as yz belongs to R. Now look at, this is equation 1 and this is equation 2. Just add this 1 and 2. Add this and you will get x minus z equal to p1 n plus p2 n. This is p1 plus p2 into n. So you can say x minus z is divisible by n. Divisible by n. So here you can say xz order pair must belongs to R. So we assume that xy and yz order pair belongs to R. That's imply xz belongs to R. So R must be transitive. So we get R is reflexive, symmetric, and transitive. When R is reflexive, symmetric, and transitive, then R is equivalence relation. थैंक यू।